Hello, and in this video on waves we're going to take a look at seismic waves, the ones caused by earthquakes. Just to be aware, this is for physics and higher tier students only. So the name given to the earthquake wave is the seismic wave. There are actually lots of types of different seismic wave, but you need to be aware of two of them. It's the P and the S wave. Let's start with the fastest ones, the P wave, the primary wave, or the pressure wave. It's a longitudinal wave. So what I've got at the bottom here is a slinky, just to show you what the longitudinal wave looks like. It's a series of compressions where the particles get close together, and rarefactions where the particles are further apart. As a reminder, a wavelength is considered from compression to compression, or rarefaction to rarefaction. As a definition to talk about longitudinal waves, or in this case P waves, it's the particles vibrate parallel to the direction of travel. So if we've got the energy passing horizontally along here, the particles are moving parallel and they're bobbing left and right, but they're parallel to the direction of energy if it's passing from the left to the right. And P waves, they can travel through both liquids and solids. More on that in a moment. First, let's move on to the other type of wave, and that's the S wave. And that is then a transverse wave. So if we think of a way to remember that, S is just an S on its side, and that's transverse. So lots of S's with transverse. And like before, we've got the term wavelength, and that's from crest or peak to peak, or it could also be from trough to trough, or from the line of equilibrium to where it starts repeating itself again. As a reminder, amplitude is only from the midpoint up to the crest, or midpoint down to the trough, not the whole height of the wave. So secondary waves, they're slower than primary waves. So primary waves are a lot faster, secondary waves come second, so they're a lot slower. And this time the particles vibrate perpendicular or at right angles to the direction of travel. So if we again imagine the energy passing from left to right, this time rather than the particles being parallel, they're at right angles. The particles are bobbing up and down perpendicular to the direction of travel. So everything's at right angles. S waves have different properties to P waves, and S waves can only travel through solids. Solids only. S for solids only. So why do we care? Well, it's because we can use P and S waves to tell us about the Earth. In fact, we can use it to tell us about the structure of the Earth, what it would look like if you sliced it in half. So P waves, they travel at different speeds through solids and liquids. And as I said a second ago, S waves can only travel through solids. So the study of these seismic waves provides us evidence of the structure of the Earth, even though we can't physically see it, but we can use science to tell us what it actually looks like. When an earthquake happens, so just here, and we'd call that an epicenter, waves, and in this case we're looking at P waves, travel through the Earth, and they can be detected at different places using seismometers that are located all around the world. Now we mentioned that waves, P waves, travel at different speeds through solids and liquids, and we can see this gets refracted as it goes through different mediums, so it slows down, bends, and keeps going. So when it's perpendicular, it goes straight through, but otherwise we get this pattern of P waves all around the Earth. And what it tells us is that P waves can travel through solids and liquids. And in a second we'll see the next picture about S waves, but it tells us that the midpoint here is actually a solid inner core, and outside it's liquid. And this is the same earthquake happening, but a different pattern, because this one is now S waves. S waves stop just here, and that tells us that it must therefore be a liquid. So the first bit here is treated as a solid, and then because S waves can travel through solids only, they don't pass all the way through, just like the P waves do.